Hello guys, welcome to my channel. So in this video I am going to explain about one of the important feature of Java 21, that is pattern matching for switch. So in the previous video, like not in the previous video, before one or two videos, in the same playlist only I have released one more video called as pattern matching for instance of. Okay, so this is the updated or the advanced version of it. So let's see what it is, and today we are taking one step further with pattern matching for switch, and this is one of the most useful features that was introduced in Java 21. So why this was introduced means pattern matching for switch. Instead of writing long chains of if else statements with the instance of, we can now use a clean powerful switch statement. So I'm going to explain how we can avoid these if else statements with instance of, and how we can switch to switch statements that makes the code look cleaner and more readable. So now let's try to understand why was pattern matching for switch introduced. Okay, so you can see it here. We have an object obj, and we have an hello string. Okay, for example, if you want to perform different actions based on the instance type, so with the help of sorry, if you want to perform based different action based on the object type, how we will do? That instance of variable. So we were in the if block. I am checking if object is an instance of string str, then I am printing string to uppercase. I am using else if object is instance of number, I am multiplying it by 2. And else if object is an instance of double, we are dividing it by 2. If it is different object, then string number and double, string integer and double, then I am going to print unknown. Okay, so actually this code works fine, there is no issue with this code. And in this case we will be getting a string to uppercase, that is the first as the output, because the given object type is of string. Okay, so this is fine, but the thing is, imagine if you have 10 to 15 object types. Okay, then you need to write like if block, else if, else if, else if, else if, some 14 times you need to write else if. Because of this, the code becomes long and very difficult to maintain. So that is why we have introduced a pattern matching for switch. So the same code, you can say object obj is equal to hello. I am switching it to object, and in the case I am writing string str. So if it is a string of type, if it is a string and the reference variable str, convert it to uppercase. If it is an integer, multiply by 2. If it is a double, divide by 2, and if it is default, you print like this. So I will show you. Okay, object obj, first I will show with hello. Object obj is equal to hello. I am switching to that object. In this case the output should be string, should be hello, should be coming in uppercase. Okay, so let's, you can see you got the hello as uppercase. Now I'll try to write uh, 20. Okay, I'll write object as 20, then I need to get to 20 into 40 as the output, because the case one integers are matched. You got the output as 40. So what happening here is, you are just switching to that object. If it is of type integer, then here only type checking and casting is happening. You no need to cast manually, everything is happening here only. If it is a string, and if it is of some other object type, for example 20d, then if I try to, you can see unknown, because integer string is only there, double is not there, so it gave unknown as the output. So this is the switch example. Okay, so I think you understood, because instead of writing long if else statements, you can use the switch statement. That is more readable, you can easily read, right? And also I'll try to explain with a real world example. So this is the real world example. So imagine you are building a payment system, and there are different modes of payment. Okay, so object payment is equal to get payment. If payment is an instance of card, then you are going to write card dot pay, some method is there. Else if it is a payment is an instance of UPI app, the UPI, then UPI dot pay. Else if, so you instead of checking like if else if else if, you can do switch to that payment method. If the then you write cases like if case credit card, then use credit card to pay. If the case is UPI, then use UPI to pay. Then default, if it's of different type other than credit card, UPI, net banking, you throw illegal argument exception saying unsupported payment. Okay, this is one of the real world example. And now let's look at what are the advantages of pattern matching for switch. The pattern matching for switch, so we are writing the cleaner code, and also even in instance of we are not doing manual typecasting, here also there is no explicit typecasting. And better readability, you can see instead of writing if else, you can see the readability of the code will be very high, maintainability of the code will be very high, and compiler checks for completeness and works with sealed classes. So you remember the last advantage works great with sealed classes. I will going to explain why. So sealed classes and switch. Actually, this is one of the important that pattern matching or switch works very well with sealed classes. This is one of the biggest advantage. So what I am doing is I am taking a sealed interface shape that permits only circle, rectangle, triangle. Okay, only three things. What I am doing is I am switching to that shape, then case circle C, then circle, rectangle, triangle. See, if I miss any one of these, instead of circle, rectangle, triangle, if I miss triangle, then you will get the error message at the show. I will show you how it works. Okay, because the interface is sealed, you can see the interface shape is sealed. The compiler knows all possible implementation, and you need to write all possible implementation. If you are not writing even one permitted type, the compiler will give you left and right. I'll show you how it will give you left and right. So okay, this is one of the simple example. I have a sealed interface vehicle that permits only car and bike. Okay, so you can see the car implements vehicle, and everything is here. So what I am doing is in the main method, in interface you can have main method, even that is possible. So vehicle is equal to new car. I am I am using a parent interface reference to hold the child class object, that is possible. So I am using, so I am switching to that vehicle. So instead of, for example, you see I have written case as car C and I am printing car, case as a bike and I am printing bike, and if any default case then no. See, you can see I am just commenting this bike. Okay, I am not removing this, and I am not writing this default as well, because if case is not, it will go to default. I am not, you can see if you are not writing default, it will show you the error message. Switch statement does not cover all possible input values. You got the output, because when you are using sealed classes with switch, this switch no, since the vehicle is sealed, interface is sealed, switch no all possibilities of vehicle. So at least if you are not having car, then you can use default. For example, I'll run this code and I'll show it to you. Now I am passing car, right? I should get car as the output. See, I got the car as the output. Okay, if I am passing bike, then since there is no bike thing, then I need to get unknown as the output. Let's run this code. So you got unknown as the output, because there is no such type. But even if default is not there, and this one knows, the bike switch statement knows there are only two implementations. But if you write bike, then the error message is gone. You can see, you can run the code and you will get bike as the output. See, you got the bike as the output. So that is what I mentioned here, the sealed classes plus switch. Okay, so this is one of the biggest advantages of this pattern matching for switch. So now let's look at some of the interview questions. What is pattern matching for switch? So pattern matching for switch is nothing but it allows the switch statement to check for the object types and automatically perform the typecasting. You got it right by the definition only. You are checking the object types here in the switch statement, and automatically Java internally performs typecasting. Does it replace instance of? No, it will not replace. It's not a replacement for instance of. Actually, instance of is used for smaller checks, smaller and simple checks we use instance of. But if there are different object like 10 to 15 object types, then you need to use switch because of its readability. And which Java feature works best with the pattern matching for switch? As I know, sealed classes, because I explained you here, right? The sealed classes works well with the pattern matching for switch. So I think in this video we have understood why the pattern matching for switch was introduced, how it reduces the long if else chains, automatic typecasting, real world example, and why it beautifully works with sealed classes. So I think we have understood everything. If you have any doubts, please feel to type it in the comment section. And I think we have only something is there. So before Java 21, so we are writing if else if, okay, like this. This looks messy, long, and it's harder to maintain. But after in Java 21, with the concept of this pattern matching for switch, we are using switch statement. We are writing cases, and the default case, it looks cleaner, readable, and modern Java. So I think that's all for this video, and thank you so much for watching.